Solar panel framing. There's a lot used on these commercial solar projects. So what can you do as a designer installer to reduce that amount of waste? Let's find out. Valley here from Greenwood. We're talking about solar rail on large commercial systems. How do we reduce the waste from a design perspective? Now, if you like what you see with these videos, hit that subscription button. Tell your friends, get them to hit the button as well. Button as well. Button as well. Button as well. Let's get stuck into it. Now, the rail used for the vast majority of solar panel systems is aluminium and is usually a construction grade such as 6005-T5 or 6106-T6. These alloys are combined with both magnesium and silicon, forming magnesium silicide, and are extremely common alloys for general purpose uses in a huge variety of industries such as, obviously construction, architecture, cars and more. In this presentation, we'll be looking at how to automatically select the best length rail for the particular row length under consideration. But first, we'll have to revisit how to calculate the row length required. First off the block is the solar panels being used, obviously. So we're going to look at the brand, model, wattage. We've got Acme 400, go Roadrunner, length 2,000 millimeters, width 1,000 mil, and the row numbers say first row, how many in a row? We're going to say 25. The number of panels in a row doesn't necessarily mean the string length, but more the max number due to the thermal expansion considerations or the physical space limitations, and we will assume the panels are in portrait in this situation. Now, ideally, in a spreadsheet, you set up in columns, so as you add rows, these can be dragged down, C to the right. So now we have to look at the spacing data. Now the mid-clamp spacing in this case is 25 mil, the end clamp spacing is 30 mil, and I've allowed an end buffer of 50 mil. And this amount is allowed for at both ends as a buffer, hence the name, and can be increased so the number of rail cuts can be reduced sometimes. Set up in columns like with the panel specs. So we got mids 25 mil, ends 30 mil, rail buffer 50 mil. So what is the final length? We have all the information to calculate the final length, which in the case of row 1 through to row 10, hey, we've added another 9 rows, is 23,710 mil. And the calculation is Y6 times AA6 plus brackets AA6 minus 1 times AK6 times 2 times, I can keep on going, but I suggest you have a bit of a look, okay? Now, this is where Y6 is the panel width and is multiplied by AA6, which is the number of panels in the row. AA6 minus 1 is the number of spaces between the panels and is multiplied by AK6, which is the gap, the mid-clamp gap between the panels. And then you add the ends clamp spaces as well by 2 because there's 1 on each end. And then you finally add the buffer of 50 mil at both ends. The AT6 reference, it sounds like a tennis tournament, doesn't it? It's for the additional top or bottom rail length to attach DC isolators. But in this case, DC isolators may be installed on the cable tray, and they usually are in the commercial applications, or not used at all due to the new AS5033 standard. We'll see about that. So you can see all the fields required to calculate the frame length are needed, and you can see that in the table below. Now, what about the frame? All panel rail manufacturers offer different lengths, and what the prudent solar system designer must do is try to reduce the amount of rail used overall, reduce the amount of wastage, and keep in mind the important material install cost ratio. I said that in my robot voice. In this presentation, we'll assume that waste lengths from one row are not used on the next. Now, a bit of a timeout from this. G'day, Gil. I said I'd mention you in this presentation, all right? Let's get stuck into it again. Time spent connecting small section of rail, cost of extra rail joiner, potential issues of structural integrity are all eliminated. So how do we calculate this? In this example, the following rail lengths are options: 3,600 mil, 4,000 mil, 4,200 mil, 4,400 mil, and 6,000 millimeter. The reality is there may only be 2 rail lengths on offer from the particular manufacturer that you guys use. Effectively, the spreadsheet will allow the designer to enter the rail length option. It will look at this option, select the best option, and show how much waste is left over. Oh, brilliant, eh? Yeah. Well, I thought so when I was putting these calculations together. It took me long enough. So the first thing is to list the rail options, and you can see that in the table next on the list. Then we have to analyse each row in regards to the frame selected and calculate how much frame is used. And we do this by dividing the length of the row frame-wise by the rail selected. And we get these results. And you can see that in the table below. And then we use these results in another formula that calculates the amount of wastage. The number nearest to 0 is the winner. In this case, both rail 2, 4,000 mil, and rail 5, 6,000 mil fit the bill. The calculation is, here goes, AY6 minus brackets, round up, bracket, G6, comma, 0.5. You know something? I'm not going to read it out. Have a look yourself. AY6 is the total frame length. G6 is that number with lots of decimal points from rail used. You round that up and you multiply that by the rail size selected. Now the cell reference L6 is the 3,600 mil rail. Now the calculation gets a bit tricky or trickier as we use a combination of offset, index, match, and max functions. Offset returns a reference to a range constructed around 1 a starting point, 2 a row offset, and 3 a column offset. Index returns the value at a given location in a range or array. Match searches for a specified item in a range of cells, returns the relative position of that item, and max returns the largest numeric value in the data provided. Well, that makes sense, hence the name max. And you can see this in the table below. Now let's see how this all works. Now with my initial design, I selected a 4,200 mil rail. So there must be a way that the spreadsheet tells you not only if your choice is good or bad, but also how much waste is involved with your choice. Now cell AP6 references the result in cell Q6 that says 4,000 mil rail is the best option, but we have selected 4,200 mil rail and the actual waste per rail, top and bottom, is 1,490 mil times 2. So maybe we should go with the 4,000 mil rail option. That's what it says, and if my spreadsheet is correct, and it is. Now you can see that the waste per row top and bottom is 290 mil times 2. Now that's a big difference between the 1,490 mil times 2 by selecting a slightly longer rail. With the particular example given, there is a possibility that by selecting the 4,000 mil rail instead of the 4,200 mil rail, that there would be no waste. And you could achieve this by increasing the buffer amount by adding an additional 145 mil to each end, so no cutting at all. Let's assume that we maintain the original buffer amount, so how much waste have we saved by selecting the 4,000 mil rail compared to the 4,200 mil rail? Let's add some extra rows. In fact, let's make it a total of 56 rows. Now we're talking system size of 515.2 kilowatts. That's a decent size system. So using the 4,200 mil rail, total wastage in meters is 168.8 meters. Now at $7 a meter, let's say, and that's an arbitrary figure, you're looking at $1,167, and we use 2,822.4 meters of rail in total. Now, if we use the 4,000 mil rail, the total wasted in meters is 32.5 meters. That's a fair reduction. And at $7 a meter, you're talking $227. and we use 2,688 metres. So just by a little bit of decent design, you have saved $940 worth of rail. Now, to calculate the waste, you simply sum up all the waste from top and bottom row and divide by 1,000 to get a metre figure, and then attach a dollar value per metre. Conclusion. The example given was fairly basic, as all the rows had an equal number of panels. Therefore, if ideal rail length was applicable to row 1, then it's applicable to all the rows. The question has to be asked, what minimum length do you use to add to the next rail if you want to join? Is adding rail worth it? There's more labour, more materials, rail joiners, etc. So at what point do we say it's not worth it? And this is something we'll look at in a future presentation. Good luck on your next project. Thanks for watching our presentation on solar panel rail and how to reduce the waste. I'm Veli from Greenwood. If you like what you see, hit that subscription button. And if you have any questions, any inquiries, or any answers, especially if you've got answers, feel free to drop us a line, and see you next time. So waste rail is pretty... it actually makes a bit of a... Yeah, I shouldn't have done that. Yeah, as my wife said, you ain't got too many brain cells left as it is. So stop hitting yourself with aluminium rail. Kids, do not try this at home.